Alright guys, in this video we are going to be critically analyzing the concepts of summation notation. So one thing you need to know is that a summation is represented by a sigma. That's the first thing we need to know. A summation is represented by a sigma. How do we write a sigma? A sigma is written like this, in this way. This is how a sigma is written. A summation is represented by a sigma. Now, the sigma, a perfect summation is written as this. It will have boundaries and the starting point, and we're talking about the series AN. Okay, now this thing looks like kind of advanced, but it's not really advanced. Now this P here, this P just tells us where the series is starting from, and this Q is telling us where we are to stop. That is the limit. Now all this will really make sense with this example. Let's take an example and let's see how this really works. Take for example, if you have something like this. Let's have we have something like this 4, and we have n equals to 1, and you are given a particular n stem of a particular series 2n plus 1. If you ask to solve something like this, it's very simple to solve. What they're just trying to tell you is that when you start adding 1 into this n, instead of writing n, you write 1, you plus it with, when you write 2, you plus it with when you write 3, until you get to 4, until you get to this 4 here. That's what this is saying. So if I want to write this now, I'll see that 2, instead of writing n, I write what? 1 plus 1, that's the first case, plus 2 into what? 2 plus 1, that's second case, plus again 2 into 3 plus 1, plus 2 into 4 plus 1. So we have to stop at 4 because the limit here is 4. That's what this thing is about. So you just simplify your work and you get your final answer. So this one, 2 times 1 is 2, 2 plus 1 is 3, so this is 3, plus 2 times 2 here is 4, 4 plus 1 is 5, so you have your 5 here. 2 times 3 is 6, 6 plus 1 is 7. Okay, very simple. Then 2 times 4 is 8, 8 plus 1 is 9. So you just have to sum up all this together and to give you the final answer. So to do this one, we are going to be having 3 plus 5, that is 8. 3 plus 5 is 8. Alright, 8 plus 7 is 15. 15 plus 9, that is 24. So the final answer for this one will be 24. That's just pretty much how to do sigma notations. Okay, let me give you one more example to get more clarifications. Suppose we have another example like this. Let me give you an example. If I have a summation, okay, 5, then n to the 2, and I'm giving the sequence or the general formula n 1 over n plus 1. Now this is saying that when you want to start adding, it should start from 2 and it should end at what? 5. So to write this one now, I will have 1 over, I'm starting from 2, not 1 now. So 2, instead of writing n, I wrote 2, plus 1 over, what is the next thing? 3, plus this one here, this one, plus 1 over, I'm writing what? 4 plus 1, then plus 1 over 5 plus 1. I'm going to stop at 5 because this one is indicating I should stop at 5. So I'm going to have 1 over 3 plus 1 over 4, that is 3 plus 1 is 4, plus 1 over 5, that's 4 plus 1 is 5, plus 1 over 6. This stuff is very simple, very simple stuff. So the LCM of these guys will be 60. It will be 60. Alright, So 3 in 60, that's 20, plus 4 in 60, that's 15. Don't forget 15 times 1 is 15, okay? Plus 5 in 60, that's 12. Then 6 in 60, that's 10. Very simple. Alright, so 20 plus 15 plus 12 plus 10, so this is 35. 35 plus 12, that's 47. 47 plus 10, that's 57, if I'm right. That's 57 over 60. Okay, so you can actually cut this one. Yeah, 3 can go in this. How do I know that 3 can go in 57? This is just a basic property of division. If you plus two numbers together and 3 can definitely go in that number. So if I do 5 plus 7, 5 plus 7 is 12. 3 can go in 12, so 3 can go in 57. That's just basic arithmetic. So 3 in 57 is 19. Yeah, there are 3 in 5, 1, then 3 in 27 is 9. So 3 in 60 is 20. So my final answer will be 19 over 20. That's just it. Now I'm going to show you the basic properties of summation notations. There are properties that you need to know while calculating. Just don't start calculating anyhow. You need to have the full knowledge of the properties. The one property is when you have a summation. When you have a summation, okay, to a constant value. Let's assume this is 6, and let's say this is 1, and you have a constant value. You are going to be getting the end point here times whatever constant that is here, and your answer will be 6c. Okay, let me give an example so that can really make sense. For example, if I have a summation of let's say it is ending at 3 and it's starting from 1, and I have 2. What this is saying that the answer will be 6. 3 times 2. That's just, you have to multiply because there's no x here that you want to do. There's no x, so you just see that is, you just multiply it, the end point and the what is it called, and the number given. That's all. That's the full concept there. Okay, so that is the first property. Now, second property that you need to know again is when you have a sigma notation like this, okay, and you have it's ending at n and it's starting from a particular number, and you have a constant value with a series. This is a series here. You have a constant value. What you are saying is that you can bring out the constant value and do your normal summation. So this is k, starting from k. Okay, do your normal notation. Let's give an example so that this can also make sense. Let me clear up this part. If I have let's assume I have this something like this, starting from 1, okay, starting from 1 and ending at 3, and we are given 6n. So instead of writing on the norms from the beginning, what we did, this will have been 1, okay, plus this will have been 2 from what we did from the introduction, right? Then this is 6 plus 12 plus 18, right, which is 36. This is brilliant, but you can also use the property as this property here. Now, how do we apply this property? It means you can bring out the constant. The constant here is 6. So this as well can be written as 6, the summation of n, stopping at 3, starting at 1. It means that you just say 6 into brackets. This one, instead of writing n, will be 1, 2, then stop at 3. You still get the same answer. This is like writing 6 into 1 plus 2 is 3, 3 plus 3 is 6. So you put your bracket here down, that will be what? 36. So that's how to use the property 2. Right, when you have a constant and the series, you bring out the constants, then you just do your computations. Now let me give you the third property. Third property for summation that you need to know when you are calculating. The third property that you really need to know. Okay, so suppose you are given something like this, a sigma. You have a sigma here, okay, and you have n starting from 1. Alright, starting from 1, and you are given this. Alright, you are given this. It means that don't forget this A and B, they are different series, right? They are series on their own. So I can divide this into 2 parts. Or whenever you have a composite function, let me just say that with a composite, that a sign is in between them, you can split it like this. This into k minus 1, you write a alone plus or minus any sign that you were given. Then you have n into k equals to 1, and you have your b, and you solve your answer. You solve for your answer, then that will be all. Let's take for example, if you have let's say you have a notation like this, stopping at 4 and starting from 1, and you have 2n plus 1. That means you can as well write this as into the notation of 4 starting from 1, okay, 2n plus another notation starting from 4 and ending at 4 and starting from 1 and for 1. You can write it like this. So to do this one, you recall from our previous property that I can bring out the constant, right? I can bring out that too. So which means that I can write this one here. I can write it as 2 into the summation, right? 4n starting from 1 and n plus. Now from the first property I gave us, that whenever you're having a constant, just multiply it with it. Just multiply these two guys. So that will be plus 4. As simple as that. That will be plus 4. Then you can as well do this one to be 2 into the brackets 1 plus 2 plus 3 plus 4, because it's stopping at 4. Then plus this 4 here plus 4. So I'm going to be having 2. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So I have 10 plus 4. Alright. So that will be 20 plus 4, and that will be 24. Right, so the whole of this one is 24. Very simple. Let me give you another property that you need to know when you are dealing with summation, because you are going to be needing all this as you move on in your studies, most especially when you get to abstract algebra. When you are dealing with mathematical induction, even reading analysis, you'll be doing all these stuffs, and you need to have basic knowledge from this stage. Alright, so when you have another one like this, suppose you now have a summation like this, right? A summation stopping at n and starting from 1, and you have just a single series. It is equal to n into n plus 1 over 2. This is actually applicable. For example, if somebody just tell you, okay, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, so when you get to 100, how will you do it? You'll be like, how do you want me to do that? You can actually use this one, because this one is just like saying 1 plus 2, because this one now, you can write this to the end stem starting from 1, right? Starting from 1, you can write it as 1 plus 2 plus 3 plus 4 plus 5 plus, so you get to n, right? So any number that is here you determine. So whatever it be the case, in as much as a single line like this, you can use this notation to cover up for yourself. So let me just use that same example I talked about. I said if you are to do 1 plus 2 plus 3 plus 4 plus 5, let's say 1 to 10. So what you just do is, this will be your 10 now. This n will be your 10, and you're starting from 1. So instead of writing 1 plus 2 and stressing yourself, you just say 10 into 10 plus 1 over 2. And 2 here is 5. Then this will be 11. So the answer will be 55. Should we check it? So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 and plus 10. Let's try it. 1 plus 2 is 3, 6, 10, 15, okay, 21, 28, 36, okay, 36 plus this is 45, and this is 55. So it's the same as the 55 we got here. Can you see that it's the same? So instead of going through the stress of doing 1 plus 2 plus 3, you can just use your n into bracket n plus 1 over 2, and that will be all. That is when it's a power of 1, right? Now, what if you have another property? What if you're asked to do 1 square plus 2 square plus 3 square plus 4 square plus 5 square to a specific number? What will you do? That's another property. Suppose you are asked to do going to n starting from 1. Make sure it's starting from 1, though, because if you starting from 2, this might not really work. So if I have k raised to power 2, that means I want to do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus whatever you are asked to do to the n squared. So suppose you are given this, the formula for that one will be n into n plus 1, okay, into 2n plus 1 over 6. This is what you want to know. This is the general formula you need to know, because you can't go through the stress of doing 1 square is 1, 2 square is 4, 1 plus 4 is 5, and that will be taking much of your time. Suppose you are asked to do something like this. You are asked to do stopping at 5, starting from 1, and you are asked to do k squared. That means you want to sum up from here to this place without wasting your time. So what you just need to do is to say 5, that means this n here is representing that 5. 5 plus 5 plus 1 into 2 5 plus 1 over 6. As simple as that. So you have 5, there is 6 here, right? That's 5 into 6. This is 10 plus 1, that's 11. Then over 6. That's all. Then you get this to cancel this one. The answer will be what? 55. Okay, you're not sure if it is correct, right? Let's try it from here. 1 squared is 1, plus 2 squared is 4, plus 3 squared is 9, 4 squared is 16, 5 squared is 25. Okay, so let's take it from here. 1 plus 4 is 5, right? 5 plus 9 is 14. 14 plus 16, that is 30. 30 plus 25, that is 55. Can you see that? It's very simple. So that's how to do those ones. So in this case, you have been able to understand how to work with summation notations. So you know that when you are given a constant, you multiply it directly with the end point. If you are given a constant and a series, you bring out the constant and you do all this stuff. Just go through the video again and understand the concepts. So that's how to do summation notations.